Hi, it's Diane again with Allied Health Career Training. Today we're going to talk about I&O, intake, output. Now when we're talking about I&O, we need to remember that a lot of very important decisions are based on your information, on the data you put in. So if you're just doing your I&O in kind of a slapshot way, people are basing big decisions on your data. Keep that in mind. What you do matters. Okay, so let's start with output. When you're measuring output, it's pretty straightforward. You're just measuring what's coming out. Now, output could be a lot of different things. We could be measuring perhaps urine in a urinal like this. It could be in a Foley catheter. You could be measuring vomit or such, emesis, and this is an emesis basin. You could also be measuring urine in what we call a hat, this. Or perhaps diarrhea or urine from a bedpan, like this. Now, when it comes to feces, you're only going to be measuring if it's liquid, a really loose stool, diarrhea. Otherwise, we wouldn't be measuring it. Now, if somebody has a colostomy bag, if the stool in there is liquidy, yeah, you're going to measure that. That would be part of an intense I&O. But if it's more solid, and of course depending on where the ostomy is located, would make a big difference on the consistency of the stool. Then you wouldn't measure it if it were solid. Okay. All right. So when you're measuring output, simply all you do is pour it into a graduate and measure it. We always measure in cc's or milliliters. We don't measure in ounces, we record in milliliters. It's always better to use milliliters than cc's because when you write 2 cc's right next to each other, if you're not careful, and especially in those really tiny little boxes they give you to write it in, it can look like zeros instead of c's. And that could really skew the data. So it's always better to write ml for milliliters because cc's and milliliters are the same thing. Okay, now for things like this, you can measure right out of the actual container. A Foley bag, a Foley catheter bag, on the other hand, better to empty it into a graduate. You have to empty it into a graduate anyway, right? So measure it from the graduate because sometimes those bags are not very reliable. And again, your data is only as good as the measurements you take. So make sure your measurements are good. Now, let me grab this real quick. So here's a good measuring thing here. And so what we would do, if this were emesis, we would empty it into the graduate, measure it. And again, we're going to be measuring in our milliliters. Of course, you put it on a flat surface. Get down to eye level with it and read what that is. And that's what you would record. Now, when you empty this, it needs to be emptied into the toilet and not into the sink. Very important. Okay, so that's output. Pretty straightforward. Of course, this is all water here, or else I would have on gloves, right? All right, now let's talk about intake. And when we're talking about intake, we're measuring things that are liquid at body temperature. So we're talking about things like Jell-O. We're talking about things like popsicles. We're talking about all the fluids they would drink. When it comes to things like soup and such, you're going to be measuring things such as tomato soup, any kind of soup that's real liquidy. If it's more of a stew, a solid stew type thing, then no, I wouldn't measure it. Now you might be saying, but Diane, there's fluid in almost everything we eat. Yeah, you're right. Also, we have insidious loss as well. You have sweat, you have breath, you have all of that we really don't have a way to measure that. So the little bits that come in that we really can't measure should hopefully be balanced out by the little things we can't measure going in. So it should balance itself out that way. Okay, now when you're measuring intake, it's quite differently and it's not quite as straightforward as output. So if I'm measuring intake, number one, I know a lot of hospitals and such will have standardized sizes The juice cups are 4 ounces, the coffee perhaps is 8. Every place will have something different. That's great, but we all know that people don't just have the hospital food or the nursing home food. Families bring stuff in, right? Yeah, they do. And so you may not know the size, and if you're working home health, you're certainly not going to know the exact size of the vessels you're working with. So I have some different coffee cups here. They all vary a lot. You can't just say, oh, it's probably about 8 ounces. You really can't do that. And some things are harder to tell than others. Okay? These can vary by 5 ounces. That's a lot. Same with these cups. Here's a few different cups that I have. Which one do you think would hold more? Okay. Did you know these two hold the same amount? Let me put them up closer for you. There we go. These two hold the same amount. Now, if you thought this would hold less, I can see why you would think that. But actually, when we pour it in, they hold the same amount. That's because this one's wider, this one's narrower. This has an insulated base, but you can't always tell by just looking at it. So you have to measure. Same with these bowls. Look at these two bowls. There's only 1 ounce difference between these two bowls. Now you might think that this one holds a lot more than this one. Not so. It's just the way this one's flared out that makes it look like it holds more. Again, don't assume, measure. You're going to have the skills to do this. Use them. So, let's say that Gladys got up and left the breakfast table, and this is what she had left. These 3 things right here. There's this little red cup here, there's the coffee cup, and then there's this little bowl. Okay, so our question is, what was her intake with these 3 items? How would we measure that? Well, you might say, well, pour it in something and measure it. Okay, so I'll start with this, dump that in there, set it down, put it on a flat surface, get down on eye level, look at it, 80 mLs. Great, 80 mLs. Is that what she drank? No. If you wrote that down as her intake, you'd be wrong. That's not what she drank. That's what she didn't drink. But that's not what I want to know. I want to know what she did drink. So how do I find that out? Because I don't know how much that cup holds. Well, first we have to find out what that cup holds. All right, so I know I have 80 milliliters left in the cup. Good enough.